Hello students, welcome back to the Tantray physics classes, and today I will deliver a second lecture on relative velocity, and I will teach you a special technique how to find relative velocity in certain cases. Okay, uh, number one, suppose you see I have to give you a special technique to find the relative velocity between the two objects. Suppose you have a particle here moving with velocity, maybe 10 meters per second, velocity v1. There's one more particle here, and it's particle 1, it's particle second, and its velocity is equal to 10 meters per second in this direction. The question is, what is the velocity of second particle with respect to first particle? Who is the observer? Observer is the first particle. What we do is that this observer who observes the velocity of the second particle transfers his velocity to this object. The observer here shifts his velocity to this object in the opposite direction, opposite to this velocity. So he gives this 10 to this object in this direction, opposite to this 10. Then he finds the total velocity here. So velocity of 2 with respect to first is 10 plus this 10, that is 20 meters per second. In which direction? If this is called as I direction, this is opposite to I, that is minus 20 I meters per second. That is all. Easily done. So what is the technique? Technique is the observer shifts his velocity to the observed particle, or the particle to which he observes or which he monitors, in the opposite direction, opposite its own velocity, opposite to this 10, he gives 10 to him in the opposite direction. That's all. It is first example. Let me go to the second example. It's a particle here. Its velocity is suppose 20, and the particle here, its velocity is 10 meters per second. It is first particle, it is second particle. What is the velocity of the second particle with respect to first particle? Velocity of the second particle is the velocity of second particle with respect to first particle. How to find it? So here, what this observer will do, what he is going to do, he will transfer his velocity to the object and will come to rest in his own frame, of reference frame. He will come to rest in his own frame and will transfer this velocity to the object in the opposite direction, means it is 20 this. He will transfer 20 to this, but in this, opposite to this 20. Now, he will observe the velocity of the second particle, the resultant of these two. So, what will be the velocity? What is the resultant of these two? What is the resultant of these two? That is, resultant can be found like this. This is the resultant. So, this object, the observer, will feel the velocity of the second particle as this. What will be that? If you write in the vector form, that is minus 20I minus 20j. If you want to write the magnitude of this, you'll write root of 20 square plus 20 square. If you want to find theta, the direction, that's tan inverse. If you want to find this theta, that is 20 by 10. That is 20 by 10. That is tan inverse 2 by 1. Tan inverse 2. That's all. So the technique is very simple. The observer transfers his own velocity to the object or to the observed in the opposite direction, opposite to his own velocity, and he comes to rest in his own frame of reference. That's all. Okay, let me go for a few more examples so that this technique is very familiar to you and you are very easy with this technique. Say, Here is an object, here is an object, okay, 2. Here is an object 1. This object has velocity 10 meters per second in the downward direction. This has velocity, okay, 5 meters per second in this direction. Let me suppose this is I and this is J. What is velocity of, okay, 1 with respect to second? Here I want this 2 is the observer. So who will transfer his velocity to the object? This 2, it transfers its velocity, this 5, will be transferred to this 1 in the opposite direction, opposite to this. That's 5 here. Now, what is the resultant of these 2? That is this. Resultant. In the vector form, it is 5i minus 10j. Magnitude, that is root of 5 square plus 10 square. And theta, tan inverse, what? If it's theta, is 5 by 10. Graphically, it can be done very easily. This is the result. So for this object 2, this is not the velocity of 1. This is not the velocity of 1. This is the velocity of 1. This one, this arrow. He transfers his velocity to this. Then he finds the resultant of the total velocity. What it already had 10 with respect to ground. And what he delivers to this object. And he finds the resultant afterwards. That is the resultant velocity. That is the velocity of object 1 with respect to object 2. Of course, when it transfers his velocity to this object, he comes to rest in his frame of reference. That's all. Now, let me give you one more example. Okay, let me give you the example which I discussed yesterday. That is... in the last lecture, I discussed that. That is umbrella and the rain problem. Why should the running man receive the rain in an inclined way, in a slanted way? That we will discuss, and using this technique. Second, rain is falling like this. Okay, let me suppose the rain is falling at 4 meters per second. It is the velocity of the rain. With respect to what? With respect to ground. With respect to ground, okay. With respect to this man. And let me suppose the person, it is a ground person for whom the velocity of the rain is vertically downwards. If he wants to save his head from the rain, he will put the umbrella like this to save his head from the rain. From the rain, he will use the umbrella in the vertical direction. Okay, now here's one more person. He runs in this direction 3 meters per second, let me suppose. 3 meters per second. So I want to know what's the velocity of the rain for this person. What is the direction of the rain for this person? I have already discussed this problem in the previous lecture, but let us do it in a different way in this by this special technique. So this man, he will transfer his velocity to the rain like this, opposite to this. He will transfer his velocity to the rain, 3 meters per second. Now rain has 2 velocities for him, this and this. And he comes to rest in his frame. So this is the resultant velocity of the rain, this one. So this is the rain velocity for him now. He will receive the rain like this. So what is the velocity of the rain for the running man? Resultant of these two, that is minus 3i and minus 4j. What is magnitude? That is root of 3 square plus 4 square. What is this angle theta? That is tan inverse. Okay, that is 3 by 4. That's the answer. So this is a special technique by which you can find the relative velocity. You have to just transfer the velocity of the observer to the observed in the opposite direction and find then the result of his actual velocity with respect to ground and the velocity which you transfer to that object in the opposite direction. Okay. Now third, let me discuss one problem which can be which is difficult to solve by other method. But if I use this method, it will be very easy to solve that problem. I will use this special technique to solve that problem. Okay. Now, Third one, the problem is like this. It is x, it is y. Here is an object at the origin. It has velocity 10 meters per second. Here is another object. It has this velocity 10 meters per second. Right? And the distance between these two objects initially, when they start their motions, is, let me suppose, okay, 20 meters. Both of them are moving. Initially, they were having these positions. This object moves up and this moves in the forward direction. And I had to find what is their shortest possible distance. What is their shortest distance before they increase the distance between them. So when they come closer, first they come closer and closer, and then distance becomes shortest, and then again they recede away from each other. So I had to find what is the shortest distance. What is the shortest distance between the two objects, B, in which time they will achieve this shortest distance. So after how much time they will reach the shortest distance, or they will have the least approach. I mean, the time in which the particles have come very close to each other. Time in which they achieve the shortest distance. These two parts of the question I want to solve by using the new technique, in which the time in which they achieve the shortest distance. Okay, these are the two questions, two parts of the same question, how it can be done. So I want to give a feel of the question before we solve it, although it can be solved by other methods also. That method may be lengthier, which is generally given in the books, but I want to solve it by this technique, but the technique that I have just explained to you. It is something like this. If I explain it before okay, let me rub it, but you already know what are the questions asked. Have a look. You see here, if I want to do it like this, have a look. It is x and it is y. It is object here, it is object here. Object goes like this and object goes like this. The object reaches here and the object goes here. Now this is the distance between them. Object is here and this object here. Now this is the distance between them. Object is here and this is object here. This is now the distance has started increasing. So there is some distance which is the shortest. There is some distance which is the shortest. Then of course the object will go straight upwards and this will go straight forward, and the distance between them will ever go on increasing. But there is a time at which the distance between the two were shortest. So what the generally books do, they get any distance in terms of x and y, and they get any distance between the two objects, and then they differentiate. And after differentiating, they put that differential is 0, and they get the answer. That is, we use calculus for that. We find any distance between the two objects, then what we do is that we differentiate the distance. Then when we put the differential coefficient of s equal to 0, then we get time, and then we substitute back into the equation, we get the distance. But that's a lengthier process. So let me see what I am going to do here. What I am going to do is, I want to keep this object, this particle at rest. This I want to get at rest, this object. In his frame, rest, in his frame. Let him move, let this object move, not this object, so that things will be easy. So what this object does, it transfers its velocity to this object in the opposite direction, that is 10 here. This 10 was like this, it will give this, it is 10 to this in the downward direction. So now this comes to rest. You have to imagine now this is not moving, this is at rest, because it has already transferred its velocity to this object in the opposite direction. Now, in which direction this object will go with respect to this object under these two velocities? It will go like this. It will go like this. With what velocity? 10 and 10, it is 10 root 2. It is the velocity now. This velocity is of this object with respect to this, because now this is the resultant of the two. Is the object, if it's second object, it is first object, is velocity of the second object with respect to first. Now, draw a perpendicular from this object here on this. Draw a perpendicular here. Draw a perpendicular. You draw a perpendicular. This was having 10 upwards velocity, which it has given to this object. This is the shortest distance, that's all. Because this is the velocity of the second with respect to first, and it follows this path. When you draw a perpendicular, any other distance is longer distance, longer and longer between the object and object. And this is the shortest one. So it is 20 here, it is 45. And this 20 has a component from here to here, that is distance is 20 cos 45, and this distance is 20 sine 45. So the answer is, without doing any kind of mathematics, just by this by this technique, shortest distance is equal to 20 sine 45. That is 20 by root 2 meters. That is 10 root 2 meters. In which time it achieves the that shortest distance? Though it takes, what time it takes from here to here? So that is the time in which it achieves the shortest distance part. So how much time it will take from here to here? Time. That is this distance divided by velocity. This distance, because it is a constant velocity, resultant of these two, this distance, that is 20 cos 45, divided by what? Velocity, that is 10 root 2. So t is equal to 20, it's 1 by root 2 divided by 10 root 2. This cancels off, it is 2 here, root 2 into root 2 means 2 again. 1 second, answer. So this problem is done so so elegantly and so lucid way by using this technique. This shifts its own velocity to this and comes to rest. Then draw a perpendicular, you find the shortest distance. Thank you, students. This was second lecture on relative velocity, and that's sufficient. But you can download more objectives, more problems on this relative velocity from the from an app, the Tantray Physics classes, from the which can be downloaded from the Google Store. Thank you.